Hello everyone, welcome to this video. I hope you're all doing great. I hope your preparation towards ISI CMI examinations is going good. Um, we'll finish algebra within 3 more sessions. Yeah, 3 more sessions, yeah. Including this, it will be 4 more sessions, I think. We'll do matrices, determinants, we'll do functional equations, and there are some other topics. So we'll cover it off. And today we are doing algebraic inequalities, right? Inequalities is a very important topic um, because here you'll see how manipulations are done. Here you'll see how graphs are useful. It's not just AMGM inequalities, it is a lot of other inequalities, like there is Jensen inequality, there is Cauchy-Schwarz inequality. You'll see all the uses of that. All right. So without much delay, let's just begin with our first with the topic of this today's lecture with the first question. All right. Look at this. Pause the video and try it out. X and Y are real numbers such that x plus y is equal to 1. The minimum possible value of x power 8 plus y power 8 is what? Which of these is that? Yeah. So, okay. So here I think we have to look at the function t which goes to t power 8, right? How does the function's graph look like? If you take s is equal to t power 8, s and t like this, yeah, it will be a concave thing. So uh, you see, if I take two values, x and y on this graph, you'll see that x plus y by 2 will be in the midpoint. You'll see that x will be here, x power 8 will be here, y power 8 will be here, and x plus y by 2 whole power 8 will be here. My point is, if you join these two lines, uh, this point would have been x. Oh, okay, just look at this. It is always there that x plus y by 2 whole power 8. And where is the midpoint of x power 8 and y power 8? If you focus that, yeah, here will be this point. Okay, let me just get some other color so that this is absolutely clear. This is the midpoint. Here will be this. Where will be the midpoint of these two? That will be a bit above, if you see it carefully. Maybe I should draw it very nicely again. Let me draw a big graph. That should be clear. So it is like this. It is a convex, concaved this side. So this will be x-axis, x-axis, y-axis. Let this be x. Let this be y. Right? X and y are here. Midpoint will be here. So this will be x power 8. This will be y power 8. This will be x power 8 plus y power 8 by 2. Okay. Here will be the midpoint. You see that this will lie here. This will be x plus y by 2, and the value of x plus y by 2 whole power 8 will be here. This will be x power 8 plus x plus y by 2 whole power 8. So you see that this is above this. So that's what we're going to write down algebraically as x plus y by 2 whole power 8 is always less than or equal to x power 8 plus y power 8. Okay, and that is what we'll be using. This is called Jensen's inequality. Jensen's inequality that comes from this convexity or concavity of a graph. And how does the graph look like? If the graph looks like this, then inequality will be flipped, obviously, right? So on in which direction is it, convex or concave? It depends on that, and you can get the point. Now, how do we use this here? Obviously, we'll use x plus y equal to 1. So we'll get x power 8 plus y power 8 by 2 is less than or equal to 1 by 2 whole power 8. All right. So we'll get x power 8 plus y power 8 is equal to 1 by 2 powers is less than or equal to 1 by 2 power 7, which is 1 by 128. Yeah. So 128, the minimum possible value. Oh, oh, this is greater than or equal to. Sorry. Yeah, obviously. Yeah, here it is. Less than or equal to. So this is greater than or equal to that. So it is greater than or equal to 128. So the minimum possible value is 128. That's the question. So Jensen's inequality introduced in the first question itself. Now pause the video, try the second question out, and let's see how that goes. Okay, so this, I think we all recognize this a plus a by 2 thing, but here the thing is a and b are related to each other. Let's say this is x and this is y, right? So x plus y will be equal to a plus 1 by a plus b plus 1 by b, and that will be equal to a plus b plus 1 by a plus 1 by b, which is a plus b by ab, which is equal to 1 plus 1 by a. Yeah, so that is easy. That was easy. Now what do we do? What can we say about ab, if I'm not wrong? Mm-mm-mm. Again, I think here we have to use Jensen's inequality to find a relation between x plus y and x square plus y square. This is then x square, what is this? So x square plus y square. So you have to find relation between that. Now a plus b is 1. Now I'll use AMGM inequality. AMGM inequality says that this is because both are positive, we are able to use that. So a plus b by 2 is greater than or equal to root ab. That will imply that root ab is less than or equal to 1 by 2. So ab is less than or equal to 1 by 4. That will imply 1 by ab will be greater than or equal to 4. So that will imply that my x plus y, which is equal to 1 plus 1 by ab, will be greater than or equal to 1 plus 4, which is 5. Now with again Jensen's inequality, can I say x square plus y square by 2 is less than or equal to x plus y by 2 whole square? Yeah, because it is again concave, it is a quadratic. So x, y, the midpoint will be here, but this will be here. So x plus y by 2 whole square is less than or equal to, oh, so this is ulta. Okay. This is greater than or equal to this. So this is how you verify, right? Even I get confused. So you have to draw the graph and you'll see that the midpoint wala value will be below the midpoint of the y values. So that's what I'm doing. Now here it is greater than or equal to 5 by 2 whole square. So I get x square plus y square by 2 is greater than or equal to 25 by 4. That will imply x square plus y square is greater than or equal to 25 by 2. So what is the options? What do we want? Minimum value. It is that. Yeah. So that's how you solve this question. AMGM inequality and Jensen's inequality together, and you'll get that. For all real, by the way, I'm following the pattern of the first two questions being single correct, single option correct, second two questions being multiple correct options possible, and last two questions are subjective. The last question will be homework in this session. So that's the plan. All right. So for real A, B, C, consider the inequality a power 4 plus b power 4 plus c power 4 being greater than or equal to this. So consider the inequality means we don't know whether this is true or not. We just playing around with this. When is this true and all? Look at the options. Which of the following statements are correct? The inequality holds for all reals A, B, C. Okay. It follows from a power 4 plus b power 4 plus b power 4 plus. If B and C are together correct, if they are correct, right? Then won't this be very, very obvious? Then this will hold true for all ABC, and for strictly positive ABC, equality holds if and only if this is happening. So maybe this that's very interesting, but how do we prove that? How do we actually prove it? All right, that's the question. So first, let's see how do we get this one. you see, um, you see, x square plus y square is always greater than or equal to 2xy, right? Because this is because x minus y whole square is greater than or equal to 0. This will follow from that. This is always true. So can I say a square whole square plus b square whole square is greater than or equal to 2a square b square, right? So from here, I can also write that for b power 4 plus c power 4 is greater than or equal to 2b square c square. C power 4 plus a power 4 is greater than or equal to 2 c square is. Now if I add all this, you'll see that this is 2a power 4 plus b power 4 plus c power 4 is greater than or equal to 2 times a square b square plus b square c square plus c square s. So that will be implying that a power 4 plus b power 4 plus c power 4 is greater than or equal to a square b square plus b square c square plus c square s. This is kind of like Cauchy-Schwarz inequality. Hmm? I think it is very similar to Cauchy-Schwarz inequality. Anyways, so what do we have? So option B is correct. Very, very nicely. So can we get this one? Do you see the product of these two? What is the product of these two? If I multiply AB into, so again, if I do that for here, what did we take? Here we took x is equal to a square, y is equal to b square, and we got that inequality. I want you to see AB into BC will be AB square C, and that's what we are getting here. So I want you to observe that. So if I take x is equal to AB, y is equal to BC, I'll get a AB square plus BC square is greater than or equal to 2 times AB into BC, right? So this will imply a square b square plus b square c square is greater than or equal to 2 times a b square c. You can get that for b square c square plus c square a square is greater than or equal to 2 b c square a. C square a square plus a square b square is greater than or equal to 2 c a square b. So if you add all of these, just look at it, I'll get 2 times a square b square plus b square c square plus c square a square is greater than or equal to 2 times. If you see, I can take ABC common, right? So I'll take ABC common, ABC, a plus b plus c. Now 2 will get cancelled. So obviously I have a square b square plus b square c square plus c square a square is greater than or equal to ABC into a plus b plus c. Now, in both of these, when does the equality hold? Equality implies x equal to y. In this inequality, what does equality mean? Here it means a square equal to b square, equal to c square if the other two are also included. So, if we are talking about positive quantities, by the way, c is correct, hence a is also correct. A, B, C are correct, no problem. For ABC positive, first equality means A equal to B equal to C if A comma B comma C are positive, right? That is very, very obvious. In the second one, what is it? AB is equal to BC is equal to CA. If ABC are positive, can you divide by ABC, 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 and you'll see that 1 by A equal to 1 by B equal to 1 by C, which will imply A equal to B equal to C again. So this equality holds, equality will imply A equal to B equal to C. So for positive ABC, the equality holds if and only if A equal to B equal to C. All the options are correct in this question. Beautiful question, if you ask me. This is a wonderful question. You should definitely expect these kind of questions. All right. So again, this again another multi-correct question. Look at this. In this question, we are given x and y are real numbers with xy equal to 1. Concerning the inequality, again, this is just concerning when is this inequality correct or not. You just have to figure it out. Think about it. I think it is very obvious that first option is correct. In general, whenever you have these kind of questions, you'll see that in multi-correct, options are hints in themselves. If there is an option A which is so obvious, so that is a step towards the other options. How do you use that option to get the results, desired results in the other options? So how do you deal with that? Let's say first of all, d equal to x minus y. Okay. So I have that d square is equal to x square plus y square minus 2. That will imply x square plus y square is equal to d square plus 2. So this is first thing, and option A is correct. Um, Again, since d square is greater than or equal to 0, this is greater than or equal to 2. That is also fine. Obviously, it is always true. What about this inequality? When do I get this one? This has to be true at some point. So, can I say something about d square plus 2? D square plus 2. Okay, I want to use maybe AMGM inequality. AMGM. So it is d square plus 2 by 2 is greater than or equal to square root d square into 2. So won't I get d square plus 2 by 2 is, this has to be used only when d is positive. No, AMGM can be used only when d is positive. Okay. Uh, so d square plus 2 is greater than or equal to root 2d. So d square plus 2 is greater than or equal to 2 root 2d. Now d square plus 2 is greater than or equal to 2 root 2 plus d, 2 root 2 into d. This is greater than or equal, this is actually exactly equal to x square plus y square. So you see that x square plus y square is greater than or equal to 2 root 2 mod d. Maybe I can write mod d. That should be good. Mod d. Now mod d is obviously greater than or equal to 2 root 2 d, which is x minus y. You see, mod x is always, mod of anything is always greater than or equal to alpha itself. It's just plus or minus. So yeah, I think we can make this inequality true. This is true for all values of x and y, for all real values of x and y. I hope you had paused the video to try it on your own. I just couldn't stop myself. Equality can occur for real values with, for some real values. So it is equal. When is this equality being held? When is the equality happening? So equality implies d square is equal to 2 or d is equal to root 2, positive value. So x minus y is equal to root 2. So only then the equality will happen. And what will be the equality? It will be that x square plus y square is equal to 4, right? 2 into root 2 into root 2. So x square plus y square is 4, x minus y is this. With this, can you solve for x and y? And xy is equal to 1. There are so many things. I think it is very easily solvable. Yeah. So that's a fair thing. And for some particular value, it will be definitely true. I don't need the exact values. Can occur for some real, absolutely. It can occur for some real value. Okay, so that's the second multi-correct question for you. Now for this question, you will need Cauchy-Schwarz inequality. How do we get Cauchy-Schwarz inequality? That is simply using the a minus b whole square is greater than or equal to formula. I won't be proving that, but I can maybe prove it for a few, for n equal to 2 or 3, and you can maybe continue it from there. All right, so look at this. What is Cauchy-Schwarz inequality? Cauchy-Schwarz inequality. It is summation ai square into summation bi square, I from 1 to n, the number of terms should be the same, is always, the square is inside, I'm sorry. Okay, is always something summation ai bi I varies from 1 to n whole square. Now you see, how do you remember which one is which? If you know vectors, you'll see that this is dot product and dot product square. And this is, if you take square root, you'll see that this is the mod of each vector. So you'll see that mod of each vector is the product of mod of each vector should be always greater than or equal to this. So I hope you see the pattern here. You can maybe put some values in and all that. And when does the equality happen? This is very important. When does equality happen? Equality implies AI is equal to some KBI for all I from 1 to n. All right. This is when they equal. So they are in the same ratio. Only then equality will be occurring. So I try to use this and solve the question. Solve this question. This is a very good question. So that's a hint that you have to use this. And I think after that you can easily solve it. Pause the video. I'll be waiting for you to pause the video because this is a very interesting question. Beautiful. All right. So I want to talk about E, right? So I'll write both in terms of E on one side. So I think I can get A plus B plus C plus D is 8 minus E. 8 minus. And A square plus B square plus C square plus D square is equal to 16 minus E square. What relation can I find? What inequality can I find in these two? Now, as I said, I need to use Cauchy-Schwarz inequality. So on one side, I will have A, B, C, D for AIs. And for BIs, if I use 1, 1, 1, 1, what will that imply? That will imply, what is summation AI? Summation AI square is A square plus B square plus C square plus D square. Summation BI square will be 4, and summation AIBI will be equal to A plus B plus C plus D. This is why I'm using this particular thing. You see what we are trying to do? Because the only option we have in Cauchy-Schwarz inequality is the sum of the squares of the terms and product of the two different terms together parallelly. So AI multiplied with BI and all that. So you have to ideally choose the very accurate this thing. And in this case, it was actually very easy. In future, I'll bring some good questions where Cauchy-Schwarz is used in a very, very tricky way. In fact, RMO PYQ, there is an RMO PYQ which uses Cauchy-Schwarz in a beautiful way. All right. Anyways, we can solve this question now. So summation AI square is this, summation BI square is this. So I'll have 4 into A square plus B square plus C square plus D square is greater than or equal to A plus B plus C plus D whole square. Now what is this equal to? This is 4 into 16 minus E square greater than or equal to 8 minus E whole square. All right. Now that's what we have to talk about. Now what can we say? Just expand it. So this is 4 into 16, which is 64 minus 4e square is greater than or equal to 64 minus, oh yes, that's nice. 64 minus 16e plus e square. All right. So 64 gets cancelled. So I have 16e is greater than or equal to 5e square. So since we are not taking, I hope we are not taking e is 0, greatest possible value. So yeah, e can be 0. So this is 5e minus 16 into e is less than or equal to 0. So that's how it will look like, right? So it is either 0, it is either 16 by 5. So it will be like this. So what is the greatest value of, so we want this to be under this. So what is the greatest value of e for this, which is possible? E can be 16 by 5. That's the good enough value, right? So this is the greatest possible value. So that's it, guys. I hope you enjoyed this. And do you notice one thing? That greatest value is happening when e is a value such that this is equal to 0. So we want this to be equal to 0. Uh, that means all of them have to be in same ratio. So A should be equal to B should be equal to C should be equal to D. So that is also a condition. And that's it. And the next question, I'll give it to you as homework. Try this question out, pause the video, and try this question out. And let me know in the comments if you were able to solve it and which inequality did you use to solve this one. All right. So till then, tata, bye bye, take care. So guys, a quick announcement. If you're interested in this video, most probably you're interested in higher mathematics which is beyond the school syllabus, beyond even the JEE syllabus, right? So if you are such a person who enjoys higher level mathematics, we're bringing a course for you named Target Math. We know that there is full math mastery, but that covers the mathematics in general. But this batch will cover mathematics in a higher level. All right, if you are interested in that, this batch is for you. It will be starting from 21st of July, so hurry up. It's going to start soon. It will be taken by the great Chetan sir. I hope you all know him. Definitely you must be knowing him. Now, who is this batch for? This batch is for class 12 students. It's for droppers. It's for ISI aspirants mainly, CMI aspirants also mainly. Or if you are simply aspiring for JEE and if you want a stronger mathematics, because JEE mathematics may not be that uh, stimulating for a lot of students unless you're doing calculus or something, but this batch will dig deeper into all the topics which are required for mathematics. If you enjoy mathematics, this batch is going to help you. Now, what are the highlights of this batch? There will be more than 95 live sessions, 3 sessions a day, 3 p.m. to 4:30 p.m. again taken by Chetan sir. UGA plus UGB pattern practice tests. So because ISI and CMI require higher level mathematics, and their pattern is in general, that's how they test, and that's why it is so good. You are going to be practicing in their pattern. Assignments every day after the session, Telegram group for discussions after the class, monthly progress report. This as constant in every batch. Now, a free bonus of ISA UGB mastery batch, right? If you're preparing for this, you'll also require preparation for UGB. If you know what UGB is, it is a subjective paper, 8 questions, 2 hours. So that mastery, writing a subjective solution is going to take some practice, and this batch is going to teach you that worth 1,000 rupees you're going to get for free if you take this batch before 21st July. Now, if you want to avail this price, please use the coupon code given below and you can avail it only for 13,000 rupees. And remember, it is 95 plus sessions covering all of mathematics in depth. So, yes, this price is definitely worth it. So, please go check it out. Link will be in the description. Please uh, go check it out. That's it. Take care. Tata. Don't forget the coupon code. Continue with the video.